All right. Good morning, everyone. So I'm planning to start the next session for machine learning ML, and this one will be on again on linear regression, but will be on multivariate. All right. So multivariate regression. So in previous situation, um, we have used area of house, and also we looked at the price. Okay. So those are the two variables. This was the independent variable, and sorry, this was dependent variable. There was one dependent variable, and this was the independent variable. Right. So basically, this one will be dependent, right? And this is based on this variable. So that's the overall idea, right? So there was only one feature. So now, what I'm planning to do is to uh, what I'm planning to do is to kind of make it more bit sophisticated by adding few other variables. So what I'm planning to do is probably to add few more features. So again, it's about house prices, right? So it's about house prices. So of course, other than the area, all right, you will find the number of bedrooms, right? So bedrooms also matters, and then age, or the how old is the house also comes into play, right? So then all that together would define the price of the uh, house. All right. Okay, so we'll try to look at some figures. Okay, so we can say right. So we can look at some figures. 2,600 is the area, and you have 3 bedrooms. So 20 years old, then 5 million, all right, or something like that, right? And if it is mm, if it is 3,000 square feet and 4 bedrooms and 15 years old, so 5.6 million. So like more the uh, number of bedrooms, more the area, this will go up, and also if it is the house age is too high, then price will go down. So the older the house, the price will go down. We think of another example, 3,200, right? And so please be sorry about my handwriting here. So I'm using a very old mouse. All right. So unfortunately, there's no values here. So there's some missing values. So when you're doing the program, we'll try to work out this, right? So probably we can fill this value, or you can omit this value, or omit the whole row. So those are the decisions that we need to take. All right. Okay. So then we will assume this is 18 years old. So what do you think? In this situation, so we can base this on the area size. So I'll say 6.1 million. So likewise, you can get a data set and get these values. All right. Uh, so this is the basic logic we are going to build now. So we have more than one feature this time. Say you have 3 features. In the previous example, there was only one feature. All right. Okay. So, all right. So now what we need to think is how we are going to model this problem as a linear regression problem. All right. So we'll get more data here. So I just wanted to give like how this data would work, and also all these are integers or numbers, quantified values, so we don't have a problem. But remember, I'll give you exercise, whereas there's another feature where you get things like words like 11, so likewise of 5. If you have this, you have to convert these words to numbers. So that's sort of an interesting problem. So Python, there are libraries like word to numbers, so you can use one of them. All right, so yeah, so the next one, yeah, um, yeah. So now what we'll do is we'll try to build a very basic equation. All right, so now of course we have the area, so we have to work with the area and the number of bedrooms. All right, and then you have the age of the house. So those are the major features, and this is also like I believe you are getting into what I'm trying to do here. So I'm going to build an equation of similar nature, so we can uh, build our regression line, right? So that's the plan. All right, so now here also we will build up coefficients, right? Build up our coefficients. So I will have a m1 here. Okay, so that's a multiplication sign, so that's a m1, and here a m2. So these are our coefficients, right? Okay, and there's another one, m3. So we have three coefficients. Previously we had only one, right? And so these are all independent variables, and this is the dependent variable, which is the price. So this is the median, right? I don't know whether yeah, so I think I said it right in the previous case, no? So these are the independent variables. So these are the independent variables, okay? So that's basically equation, and these are the coefficients, all right? M1, M2, they are the coefficients. Okay, they are the coefficients, all right. I think I am right here also. Okay. All right. Then once you do this, of course, we forgot to mention there should be the b, and that should be fine, right? So now we have the equation in this format: y equals m1 x1, which is area, m2 x2, which is bedrooms, and m3 x3, which is the age of the house, and the b. So that would be the basic multivariate LR model, right? So once you have this, I think we are ready to go and test this model in our code. Hope this part is clear to you all. Yes. So now let me get my PyCharm. Right? So leave this here. Okay. Just give me a second. Okay. So then I will create a file here. So I'm going to create a new Python file. Okay, and I will name it as multi. Alright, so that will do the trick. So now I'm going to start writing my code. All Alright, so we'll first import pandas, okay, and then we need the numpy, and we need the scalar. So these are the same libraries we used right in previous time also. And this time I need this CSV file. So I'm going to have multi. So let me open the CSV and show it to you. Yeah, so as you can see, okay, so you get these values: bedroom, age, price. There's a missing value here, so we'll try to work on this when you're doing the code. Right, so these are the values. So what I'm going to do now, I'm going to load this into my environment. All right, so I'm going to drag and drop it. Okay, so I have this file. All good. Okay, then now what I'm going to do is, using the pandas, I'm going to read the CSV. So it's actually the home prices. That's my new file. Let me check. It's not the file. Okay, so I have accidentally put it in the environment folder. Now it's in the right place. So now I can load the CSV, and I'm going to get it into the data set. So I would say F. So that'll be easier. Then I can print this data set and run this program. So let's see. Yeah, so you can see the data set very clearly. So there is one problem. So there's no missing value here. So other than that, everything is fine. Okay. So I don't need this anymore. Okay. Then what I'm going to do, I'm going to, the best strategy is to here to fill this missing value. So I would try to do or get a median, right? So to get the median, I would go to the data set and get the bedrooms. So yeah, bedrooms, right? Okay, bedrooms, and then media. Okay, so that would do, and we'll see what is the median value of this column. Okay, let's see whether what's the value that we're getting. Okay, so I think we have to print this. Okay, now we'll see. Okay, so we get 4. So obviously when you look at those values, so the median would be 4. Fine. So now what we have to do, get this value and fill it to the data frame. So I'll leave it there. I'll copy this bit, which I have to feed into the data frame. To do that, using this function, okay, call fill the missing values. So that's this function called fill in. Okay, so basically this should go there. Okay, that's cool. So then that got to be added to the column bedrooms. Alright, so that would do the trick. So now what I'm going to do is just to print df and see what would be the new value. Alright, so now you can see there is no missing value, right? There's no missing value. So I can print both and see the difference. Okay, so we'll wait for the output. As you can see, there's a null value and no null value here. So that did the trick. Alright, so now we have a complete data set to take to the next step, which is setting up the linear regression. So like in the previous time, there's no much difference. It's the linear model and then linear regression. Alright, and so we create object reg like in the previous time. Okay, so you can see the variables are getting set up here, reg. Alright, and then so now the variable is there, regression variable, so I can start doing the regression. So it's in the fit function. Now we have to provide the values. Alright, so basically I have to provide all these values: the area, bedrooms, age, other than the price. So that's what I'm going to do. Okay, that's what I'm going to do. Okay, so now as I said, I had to send those columns without the price. So to do that, I will drop the price column. And then the price column. So it's the column, it's the axis column. Alright, that will do the trick. And next we have to set the price separately as the dependent variable. Okay, that would do the trick. So with the fit function, and then the price axis df price. Looks good. So we'll run this. Command Shift R. Okay. I won't be getting any outputs. That's okay. Okay, so now what I had to do, I can build the equation like the previous time, right? So I need to get the coefficients to do that. So I need the coefficients, right? To get the coefficients, I would do a print. Okay. Okay, I will do a print, and inside the print, I will call range coefficients. Okay, so printing the coefficients. Okay, run this. All right, so I get this is the first one, this is the second one, and this is the third one. All right, so that's good. And then the intercept, which is b, sorry, it is b, is intercept. So intercept. So we're going to print this. Okay. All right. So I'm getting this as the intercept. So obviously now everything is ready for prediction. Okay. So everything is ready for prediction. So let me predict. Okay. So unlike this previous time, I need to send a okay, so, array of values, right? So I would select a few values, 3000. So so I can have any value. So I'll have value like 3000, and bedrooms 3, and age of the house I would say 30 is there, no? So I say 40, right? Okay, so now they should come up with a value. So what do you think? It's almost like this one, but because it's 15 or it's 5.6 something, if you put 30 or 40, I think this should go down, right? So this should go down. So let's check. So that's our common sense. Let's see whether our common sense is correct. Okay. Okay. So I'll run this. All right. So now once you do that, of course, you get a value which is below than this value. Okay. So the prediction was done. Right. So you can see the value. So that's what we need, right? So now we can, if we needs to build up that equation. So I'll not really worry about that. So if you want, you can get those coefficients and build up the equation like we did the first time. And probably we can do another prediction. And remember, in our previous example, we did feed a new Excel sheet with some new values. So we can do the same again, right? Okay, so this time I'm going to feed 2500, and 4 bedrooms and 5 years old. So this should be obviously more than bigger than the previous one. Okay. Looks okay. So let me run this now. All right. So you guys can see that it's 57 something. So obviously the price is high. So the common sense says it can be correct. All right. So next the exercise. So basically I'll open this file. So you'll have a Excel sheet, so which I'm going to put it in my GitHub. All right. So basically what you have here, so try to build this code, guys. Uh, okay, so try to observe what is here. So what you get is some experience values of some employers, potential employees, right? So you're going to do an interview and you get a test score out of 10, right? And then the interview score out of 10. So then you have to decide on the salary levels to give to the so the interviewed people. So there are a few issues. So it's again like the same problem, similar type of problem, but there are some challenges. There's a missing value which you should fill, so you can use the median. And these two values, experience, maybe they don't have experience, so you don't have to exactly fill these values. But one other problem is this is in Word, so you have to convert Word to vector or Word to numbers. So for that, you'll be able to find some functions in Python like this. All right, so I think in NumPy you'll find it, or else that should be other libraries. So this will be available in the GitHub. So please get this and try to do that exercise on this one. All right. So this is your second one. Second one. So next one I think I'm planning to do on. So that also I'll be doing today. We missed few lectures, so I think the next one will be on gradient descent. So we'll learn a bit about cost function as well, and we'll do exercise on gradient descent. And next to follow is one-hot encoding. Right, so then we'll follow some test split, and then logistic regression, and decision tree, SVM, random forest, k-fold, k-means, like so that's like the plan. All right, so hope you're enjoying the sessions, right? And also make sure to do them by your own. All right, that's the key. Okay, so see you in the next one.